All right, these are your notes for section 11.2, and there'll be a quiz on Edmodo also, just a quick 2 or 3 question quiz if you knock out, just so I'll know that you watched the video. Section 11.2, we did notes on 11.1 in class today. But this is arithmetic sequences. We talked about sequences today. An arithmetic sequence is a unique sequence, and the definition of an arithmetic sequence is any sequence. My writing's going to be crap. Oh well. Is any sequence, that's really bad, where the difference and difference is a key word. It means you're subtracting, right? Difference between any consecutive terms is constant. In other words, you're always adding or subtracting the same thing to each term to get to the next term. Just a few quick examples of an arithmetic sequence. Again, it's any sequence where the difference between any consecutive terms is constant. A few examples would be like the sequence 2, 5, 8, 11, 14, and so on and so forth. If you look at that sequence, from one term to the next, you're adding the same thing each time. In this case, we're adding 3 plus 3. 8 plus 3 is 11. 11 plus 3 is 14. So that is an arithmetic sequence because you're adding the same thing to each one to get to the next number. You could also be subtracting. Addition and subtraction are kind of the same. So we have, so if I had 20, 16, 12, 8, 4, 0, and you can go into negative numbers, nothing wrong with that, dot, dot, dot. If you look at this, doesn't matter which 2 terms you choose to get from one term to the next, we're always subtracting the same amount. Always subtracting the same amount to get from one term to the next. Both of those are arithmetic sequences. The number that you either add or subtract, that number, in this case, positive, where'd that plus 4 come from? Let's fix that. There we go. In these cases, the number that you are either adding or subtracting to get to the next term, that is referred to as the common difference. The common difference is what those numbers are. And we'll refer to the common difference as simply D. It's a number whatever you're adding or subtracting to get to the next term. If I ask you to write out the first 5 terms, it's going to be a lot like what we did in class today. Plug in, starting with n equals 1, going through n equals 5 if we're doing the first 5 terms. So this one right here, if I plugged in 1, that's supposed to be black. There we go. If I plug in 1 for n, 3 times 1 plus 2 is 5. 3 times 2 is 6, plus 2 is 8. 3 times 3 is 9, plus 2 is 11. And after a while, you start to see the pattern. I'm telling you that they have a common difference. If there is a common difference, that means they're arithmetic. And once you can figure out what you're adding, then you could quit plugging in numbers to the original formula. You can say, well, I just need to add 3 each time. So now I'm to the point where I'm just doing 11 plus 3 is 14, plus 3 is 17. And I wanted to stop with the 5th term, so I stopped right there. It says find the common difference, and your common difference in this case, D, is 3, because that's what we're at. If you look at this one, this is going to be a little bit uglier because there are fractions. Half of 1 is 0.5. 0.5 minus 3 is negative 2.5. Half of 2 is 1. 1 minus 3 is negative 2. Half of 3 is 1.5 minus 3 is negative 1.5. Half of 4 is 2 minus 3 is negative 1. Half of 5 is 2.5 minus 3 is negative 0.5. They're my first 5 terms. And if you look at that, my difference, I am increasing each time, and I'm adding 1/2 plus 1/2. So there's my difference. D is 1/2. Right here, negative 2n plus 4. First 5 terms start by plugging in 1 for n. Negative 2 times 1 plus 4 is 2. Negative 2 times 2 is negative 4 plus 4 is 0. Negative 2 times 3 is negative 6, plus 4 is negative 2. 2 times 4 is 8, so negative 8 plus 4 is negative 4. Plug in 5. Negative 10 plus 4 is negative 6. There are my first 5 terms. And each time I am going down by 2. So my common difference is negative 2. One thing you may notice, and you may not have, I don't know, you're probably just barely watching this. Your common difference, if you look at all of the arithmetic sequences, they all kind of, if you think back to when you first started graphing line, they kind of resemble that mx plus b format, where I have something times n plus a number, something times n plus a number, something times n plus a number. Just like your slope-intercept form is something times x plus a number, your arithmetic sequences can be written in that slope-intercept type form. And if you're really paying attention, you'll see that the common difference is 3. That's what the slope was. The difference was 1/2. That's what the slope was. The difference was negative 2. That's what the slope is. So when you're writing formulas for an arithmetic sequence, an arithmetic formula resembles slope-intercept form. I'm kind of put a little box over here. An arithmetic sequence value formula resembles slope-intercept form. And that's your old-fashioned y equals mx plus b, where the common difference is the slope. And then you have to use other stuff to find out what b is, but you notice the common difference is the slope. And we'll use that on these kinds of problems. Let me go back. Y'all need to write that. Y'all got that? It's on video. You can pause it. Write the formula that gives the following arithmetic sequence. And I'll just make one up real quick. Let's say I had the arithmetic sequence 7, 12, 17, 22, 27, and so on and so forth. It doesn't end, it goes forever. I know that it's going to resemble, I'm kind of over here in thinking land, it's going to resemble slope-intercept form mx plus b, or if we're doing arithmetic sequence, instead of x, we'll do slope times n, where your slope is the same thing as the common difference. So really the first thing I'm going to do, if I want to find a formula for this, I want to find the common difference. So my difference, I'll look at this, I am adding 5 each time, plus 5, plus 5. So my common difference is 5, which means I know this formula is going to be 5 times n, because my common difference was 5, so it's 5n plus some number, and then we have to figure out what is that number we have to add. And the way I figure that out is I know my first term is 7. I know a sub 1, my very first term is 7, and that's when n was equal to 1. So I'll simply plug in 1 to this formula. My formula is 5n plus something, and when I plug in 1, I need to get 7. So 5 times 1 plus some number, because my first term, when n was 1, was 7. That needs to give me 7. Then I just figure out, okay, 5 times 1, that's 5 plus some number equals 7, and use your advanced math to figure out that that number has to be 2. So my formula is 5n plus 2. And you can test that out real quick. If you look at the fourth term, this is when n was 4. If I plug in 4 real quick, 5 times 4 is 20, plus 2 is 22, so that tests out okay. So that's one way you can write the formula of an arithmetic sequence. Let's see, moving on, finding the nth term of an arithmetic sequence. A bunch of math lingo here. To find the nth term, where you have the first term, a sub 1 is the first term. D is the common difference. The way you find the nth term is kind of a lengthy formula, but it's your first term plus n minus 1 times whatever the common difference is. So there's your formula. A sub n is first term plus n minus 1d. So if I want the 8th term, and I'm going to use this formula, the 8th term, that means n is 8. So a sub 8 is my first term plus n minus 1, which is 8 minus 1 times the common difference. And then we simply plug in the first term and the common difference. So in this case, a sub 1 is 4, and my common difference is 2. And then we'll just plug that in. So 4 plus 8 minus 1 times 2. 4 plus 7 times 2. 7 times 2 is 14. So 4 plus 14 is 18. And there's your 8th term. The 23rd term of an arithmetic sequence. And this one, notice I didn't explicitly give you the first term and the difference. I gave you the first term, and then I wrote out some terms. We have to use our high math skills to figure out that I'm subtracting 3 each time. So there's my difference. D is negative 3. And I'm going to use that exact same formula. My 23rd term, a sub 23, is my first term, a sub 1, which is 8, plus, I'm looking for the 23rd term, so 23 minus 1 times the difference is negative 3. And then we'll simply work that out. 8 plus 22 times negative 3, that's 8. 22 times negative 3 is negative 66. 8 minus 66, geez, what is that, negative 58? And so that is what the 23rd term is. Yeah. So finding the nth term of an arithmetic sequence, we're using that formula, and you do need to know these formulas. Same type question, find the 10th term, that's asking for a sub 10. For these sequences, where there's my first term, a sub 1 is 1, and my common difference, you have to figure this out, we're going up by 3 each time, so the difference is 3. So if I want my 10th term, I know the formula, I'll rewrite it again, it's your first term plus n minus 1 times the common difference. So a sub 10 is my first term, which is 1, plus 10 minus 1 times the common difference, which was 3. So that's 1 plus 10 minus 1 is 9 times 3. 1 plus 27 is 28. There's your 10th term. We won't do this one just for the sake of saving time, but you would use first term is 2, and the difference, 11 over 2 is what, 5.5, so the difference looks like 3.5. And then you'll plug 2 and 3.5 and 10 in for the A1, N, and D. The last thing, finding the sum of an arithmetic sequence. How am I doing on time? 12 minutes. All right. Finding the sum of an arithmetic sequence. This turns it into a series. So for finding the sum, the formula for the sum of an arithmetic sequence, remember sum is when you're doing that sigma notation. If we started with 1 and went up to any number of terms, I can go to the 8th term, I can go to the 12th term, but if I have some sequence from 1 to n, the sum of an arithmetic sequence, there are 2 formulas. I'll go ahead and give them both to you, but I'm going to use this first one because it works more often than the other one. So it's n over 2 plus 2 times the first term plus n minus 1d. That's one formula. Or it equals, and this one's a lot cleaner, but we usually don't have the last term. N over 2 times a sub 1 plus your last term. So we could use this one. You need the number of terms, your first term, and the common difference. This one you need the number of terms, the first term, and the last term. And we usually don't have the last term, so I usually don't use this formula. A sub n is the last term. So like right here, number B, if I want to evaluate this sum, I'm starting from 1, going to 14. So I know I'm doing 14 terms, so n is going to be 14. And what I'll always do is write out the first couple of terms just so I could see it. I'll plug in 1, negative 5 plus 8 is 3, plus, if I plugged in 2, that'd be negative 10 plus 8 is negative 2. If I plugged in 3, negative 15 plus 8 is negative 7. That's 3 minus 2. So they're the first few terms of my sequence. And I can look at this. I like to look at this thing because I can look at that and see my first term is 3, and my common difference, you can do the difference 2 different ways. You could say, okay, 3 to negative 2 is subtracting 5. Negative 2 to negative 7 is subtracting 5. Or you could remember that the coefficient of n is the difference. There's a couple of different ways you could do that. But now I have my terms, first term, and the difference, and we'll plug it into that formula. So my sum is going to be n over 2, 14 over 2, times 2 times my first term, a sub 1, which was 3, plus n minus 1, that's 14 minus 1, times the common difference of negative 5, and from there it becomes order of operations. 14 over 2 is 7, times 2 times 3 is 6, plus 14 minus 1 is 13, times negative 5. What's 13 times negative 5? I think it's 65. 13 times 5 is 15, carry the 1. 65, I was right. So 6 minus 65 is 59, I believe, negative 59. And I don't have my calculator with me. I really should have gotten my calculator. So 59 times 7, that's 63, carry my 6. That's not a 6, carry my 6. 35 plus 6 is 41. Holy cow. So negative 416 is going to be the sum. If I were to write out all those terms and add up all 14 terms, I would get negative 416. I'll do one more, and then we'll call it, which one should we do? Let's do number 8. We won't do number 7. All right, we're finding the sum from the first term, from n equals 1 to 24. So I know there's going to be 24 different terms. And if I write out my first few terms, if I start with 1, negative 1 plus 4 is 3, plus, if I plug in 2, negative 2 plus 4 is 2. If I plug in 3, negative 3 plus 4 is 1, so on and so forth. I can look at that. I can see, well, we already know there's 24 terms because I go from 1 to 24. I can look there, and I can see that the first term is 3. And I'm going down by 1 each time, so I can look at this and see that I'm subtracting 1, and my difference is negative 1. And remember, your difference is also the coefficient of n, which in this case is negative 1. And then my sum of my first 24 terms, that sum is going to be n, the number of terms, divided by 2, times 2 times the first term. My first term was 3. Base of 1 is 3, plus n minus 1, 24 minus 1, times the common difference, which is negative 1, and then order of operations after that. 24 over 2 is 12, 2 times 3 is 6, plus 23 times negative 1 is negative 23. 6 minus 23 is negative 17, times 12, and again, I don't know my multiplication tables very well. 12 times 17, that's 14, carry my 1, that'd be 3, and then 17, so what's that, 204? So negative 204 is going to be the sum of all the terms. So that is a quick blitz of your arithmetic sequences. Let's see, starting here, arithmetic sequence is when you are adding the same thing to get to the next term. You can either add or subtract. Like here, I'm adding 3. You can subtract to get to the next term. Writing out the first few terms is exactly what we did in class today. Notice that in your formula, this number right there is basically like the slope, going up by 5 each time. So it was 5n. Let's see, I'm really trying to just hit the highlights here. Formula for finding the nth term. What else do we do right there? Finding the 10th term and finding the sum of them. So that's everything there is. We'll do some problems on this in class tomorrow. And yeah, we'll see how this goes. Peace out.